Ah, baseball. America's pastime. Do you know what else is America's pastime? Trying to take any sport and label the best and worst teams or players through numbers. Baseball is the pinnacle of this, with there being stats for everything under the sun. I wouldn't even be surprised if there are stats for about how a sun angle affects a player's batting chances. All jokes aside, I think that stats used in baseball add extra depth to the sport. I find them quite mesmerizing and deepen my enjoyment of baseball. Do you know what else I enjoy? Making math animations. If you see my Instagram, you can see I make a lot of them. As such, an idea formed in my little monkey brain. Take baseball stats and make them into a math animation. The baseball stats will become art. My first task was, of course, picking which stats I would use in order to attempt this. I decided to use the triple slash and OPS because they are pretty much the building blocks of all other stats. My second order of business was deciding which player's stats to include in my data sheet. I decided, very arbitrarily, that I would pick the player with the best average from each team as of May 4th, 2022. This would give me 30 different data points, and the players won't all be superstars. After I put all my data in a spreadsheet, I went to Desmos to play around with the data. First, I did something very simple. Each stat would be the x and y coordinate of itself. So it would be average, average, OBP, OBP, etc., etc. And who would have thought this forms a straight line with x equals y? Who would have believed it? Way to go past me. You are truly a genius. And then I realized something very simple. These stats could easily be used as coefficients. Coefficients can turn very simple equations into monstrosities of their former selves. For example, see this weird shape right here? What do you think the base formula for this graph is? If you said a circle, you would be correct. Specifically, the parametric equation of a circle with these coefficients. So what if you take equations for some shapes and just slap some batting average on it? I decided to try it on two different shapes. First, a circle, and second, that Limason formula I did a bunch of stuff with last video. The formula will never die. It will always come back. I also decided that I will give the coefficients in order they appear in the triple slash, with OPS tacked on at the end. So let's try it and do it to the circle formula. And wow, that is a mess. Basically, what I did next is throw these arrays into Python and then reordered from lowest to highest numbers, because if I didn't do that, then everybody would get a lepsy. This also had the added bonus of giving a growing and shrinking effect, and while this doesn't represent actual players anymore, it still uses stats to create very interesting shapes. For the Limason one, I followed the same philosophy as the circle. Take the formula and throw the stats from left to right on it. This gives you this mess right here. Again, I threw the arrays into Python and reordered from lowest to highest to give an illusion of growing and shrinking. Here are both animations. Now, using numbers as coefficients is all fine and all, but what about making a function from the numbers? Using the power of linear regression, we can do that. I decided to again just graph the stats in triple slash order and tag on OPS at the end, which gives you this spray of points. Now, I don't know about you, but I see a function that looks kind of like this. Desmos doesn't like doing linear regression with arrays, so I mainly picked some points that more or less makes up this function I saw. I used the first and last x values as the range of the function I would use. I then moved the function down to the x-axis, because I could. Do you know what would be cool? If you can take this function and spin it around the origin at any angle whatsoever. After watching this video here, which is super good by the way, I took what I learned and applied it to the function Desmos spit out. I also applied it to the inverse of the function, because usually if you have a function and you have an inverse function, they make pretty cool stuff. And now we can spin both of them around, like a record. In Python, what I did was simply create a snapshot, if you will, of where the function is at any angle. Doing this over one complete rotation gives a really cool design, which is shown here. And here is the complete animation. Now, what did we learn today? I think we learned very important things, such as if you put your mind to it and bend the rules to your will, you can make numbers do whatever you want. I think that's a great lesson to learn.